Hello students, today we will discuss about solution of linear differential equations. First of all, we will see what are linear differential equations. The equations which are in the form of dy over dx plus py is equals to q. The equations which are in the form of dy upon dx plus py equals to q. These equations are called linear differential equations, or second form of linear differential equation is dy over dx over dy is equals plus px is equals to q. So these two equations are linear differential equations. Now we will see what are the solution of these linear equations. The solution of this first linear equation, this will be y into if is equals to integral q into if into dx plus c, where the value of if, integrating factor, if means integrating factor, this will be e to the power integral p dx. Correct? Now we will see what is the solution of this second type of linear equation. This will be x into if is equals to integral q into if into dy, where the value of integrating factor if will be e to the power integral p dy. So students, these are the two solutions of these linear equations. You will remember these solutions. So we can solve all the questions related to these types. Students, our question number 1, dy over dx plus 3y is equals to e to the power minus 2x. We can see this is a linear differential equation. We have to find solution of this equation. So we are comparing with standard form. So comparing with dy over dx plus py is equals to q. We can see here the value of p, this is 3, the value of q e to the power minus 2x. Students, we will find here if, integrating factor, because we have to put the value of if. So the value of if will be e to the power integral p dx. E to the power p. What is the value of p here? This is 3 into dx, integral of 3x, 3 into dx, this will be 3x. The value of if, integrating factor, this will be e to the power 3x. Now we can see solution of linear equation. This will be y into if is equals to integral q into if into dx plus c. Now we will put the value y, the value of if we have e to the power 3x is equals to integral the value of q is e to the power minus 2x, and if, the value of if is e to the power 3x into dx plus c. Students, we will solve this part. You can see here y e to the power 3x is equals to integral, we will solve e to the power plus 3x, e to the power minus 2x, so this will be e to the power x after solving, dx plus c. Integral of e to the power x, this will be e to the power x plus c. So this will be the solution of this linear differential equation. Students, now we have dy over dx plus y upon x is equals to x square. So we have to find solution of this differential equation. This is also a linear differential equation. We can write it dy over dx plus 1 over x into y is equals to x square. Now comparing with the standard form, comparing with dy over dx plus py is equals to q. We can see here the value of p is 1 upon x and the value of q, this is x square. We can write here p is equals to 1 upon x and q, this is x square. Students, we will find here if, integrating factor. This will be e to the power integral p dx, e to the power integral, the value of p, this is 1 upon x into dx, integral of 1 upon x, this is log x. So e to the power log x, now e and log cancel out, so we'll get here x. The value of e to the power log x will be x. Now what is the solution? Solution of equation. So this will be y into if is equals to integral q into if dx plus c. This is the solution of this linear differential equation. We are putting the value of if. Students, you can see here if integrating factor, we have got here x is equals to integral the value of q, this is x square, and the value of if, this is x dx plus c. X square into x, this will be x cube dx plus c, y into x. Students, what is the integral of x to the power 3? This will be x to the power 4 upon 4. So y into x is equals to x to the power 4 upon 4 plus c. This is the differential. This is the solution of this linear differential equation. Students, now we can see here cos square x dy over dx plus y is equals to 10x. We can see in the standard form the coefficient of dy upon dx will be 1. We can see here what is the standard form, dy over dx plus py is equals to q. What is the coefficient of dy over dx? This is 1. But what is the coefficient of dy over dx here? Cos square x. What will we do here? We will divide by cos square x in all the terms of this equation. Dividing by cos square x, we will get here dy over dx cos square upon cos square 1 plus we have 1 here, we will divide by cos square, so we will get here 1 upon cos square means sec square x into y is equals to 10x upon cos square x. So this will be 10x upon cos square x, so this will be 10x in numerator, this will be sec square x. Okay, now comparing with standard form, what is the value of p? P will be sec square x and q will be 10x into sec square x. Students, will find integrating factor. The value of if, this will be e to the power integral p dx. What is the value of p? This is sec square x into dx. Integral of sec square, we know very well, integral of sec square is 10x. So the value of if, integrating factor, this will be e to the power 10x. Now what will be the solution? Solution will be if into y, or y into if is equals to integral q into if into dx plus c. The value of if is e to the power 10x. So y into e to the power 10x is equals to integral the value of q. What is q here? 10x into sec square x. And the value of 10 if is the value of if 10x sec square x, and q, the value of, sorry, the value of if, this is e to the power 10x, e to the power 10x into dx. Correct. Now what will we do here? We will do by substitution method. We will write here let t is equals to 10x. In this integral, we are we are solving this integral part. Let t is equals to 10x. So differentiation of this part dt upon dx, this will be sec square x. Now substituting this value in this integral, we will get here y e to the power 10x is equals to integral sec square x into dx. So this will be dt and this will be t e to the power t. Students, we will use here integral by parts, means product rule in this part. So we will write here, this is our first function, this is your second function. First into integral of second e to the power t, integral of e to the power t, this is e to the power t, minus integral differentiation of first, this is 1, integral of second, this is e to the power t, and plus c, y into e to the power 10x. Correct? Now integrating integral of e to the power t, this will be e to the power t plus c. Now we are putting the value of this t. What is equals, what is t? T equals to 10x. So this will be y into e to the power 10x is equals to 10x into e to the power 10x minus e to the power 10x plus c. So this will be the answer of this linear differential equation. Students, our equation is x log x dy upon dx plus y is equals to 2 upon x log x. Again, we can see here the coefficient of dy upon dx is x log x. So dividing by x log x, we will get here dy over dx plus 1 upon x log x into y is equals to, we are dividing by x log x, so we'll get here 2 log x upon x into x log x, means x square log x. Log x cancel out, so this will be 2 upon x square. What is the value of this p? This is 1 upon x log x. And what is the value of q? This is 2 upon x square. We are finding integrating factor. This will be e to the power integral p dx. Integral, the value of p, this is 1 upon x log x into dx. Correct? Now we will write here, let t equals to log x. We are doing integral by substitution method. So let t is equals to log x. Differentiation of this part, this will be 1 upon x. Now if we will substitute the value, so the value of dt is 1 upon x dx. Dx upon x, this will be dt e to the power integral dt over t. So integral of dt upon t, this will be log t. Now you can write it t. And what is the value of this t? T is log x. So after solving, we are getting if equals to log x. Correct? Now students, we are finding solution of this linear differential equation. We know very well, this is y into if is equals to integral q into if into dx and plus c. We are putting the value of if. If is, what is the value of if? This is log x. Log x is equals to integral q. The value of q is 2 upon x square into if, this is log x plus dx plus c. Correct? Now this is your first function, this is your second function. We are doing integral by parts. So this will be y into log x is equals to first into integral of second. Correct? Minus integral differentiation of first, differentiation of log x 1 upon x into integral of second, then whole integral. What will we do here? We will find the value log x into, this will be 2, and we can write it x to the power minus 2 into dx minus integral 1 upon x into, we can write it integral 2 into x to the power minus 2 into dx. Correct? Now this will be 2 log x and integral of this part x to the power minus 1 upon minus 1 minus integral 1 upon x, this will be 2, and we can write it x to the power minus 1 upon minus 1 into dx. This will be minus 2 log x over x minus integral, this will be minus minus plus 2, we can write outside the integral, so we will write here 1 upon x into x square, we can write it 1 upon x 1 upon x 1 upon x square, and in numerator this will be x to the power minus 2, so this will be 2 log x upon x plus 2 integral x to the power minus 2 into dx, so this will be minus 2 log x upon x plus 2 x to the power minus 1 upon minus 1. This is the value of y log x, y log x. Or we can write one more line, y into log x is equals to minus 2 log x over x plus minus minus 2 over x. So this will be your answer. Students, our next question is 1 plus x square dy plus 2xy dx equals to cot x dx. We will convert this linear equation. We will convert this equation into linear equation. Dividing by 1 plus x square dx. In this whole equation, we are dividing by 1 plus x square into dx. What will we get here? 1 plus x square dy over 1 plus x square dx plus 2xy dx upon 1 plus x square dx is equals to cot x dx over 1 plus x square into dx cancel out, dx cancel out, this part is cancel out, so we'll get here dy upon dx plus 2x upon 1 plus x square into y is equals to cot x upon 1 plus x square. Students, when you will compare with the standard form, so the value of p will be and the value of q will be cot x upon 1 plus x square. So we will find here integrating factor, this will be e to the power integral p dx. The value of p, we know very well the value of p is 2x upon 1 plus x square into dx, and this will be e to the power integral of 2x upon 1 plus x square is log 1 plus x square. Now log and e are cancelled out, so the value of if will be 1 plus x square. This is the value of if. Now what will be the solution? Solution of this differential equation will be y into if is equals to integral q into if into dx plus c. We are putting the value of if. The value of if, this is 1 plus x square is equals to integral. The value of q, this is cot x over 1 plus x square into if. The value of if, this is 1 plus x square into dx plus c. Now this term is cancelled out by this term. We have got here y in bracket 1 plus x square is equals to, we have integral cot x. So integral of cot x will be log sin x. Integral of cot x will be log sin x plus c. So students, this is the solution of this linear differential equation. Students, our question is 1 plus x square dy upon dx plus 2xy is equals to 1 upon 1 plus x square, where y equals to 0 and x equals to 1. Students, we have to find particular solution of this differential equation. When x and y are given, then we will find a solution and we will find the value of c. So this solution will called, we can solve, we can say this solution particular solution, means solution will be particular solution. First of all, the coefficient of dy upon dx should be 1. So dividing by 1 plus x square in this whole equation, we'll get here dy over dx plus 2x upon 1 plus x square into y is equals to 1 upon 1 plus x square whole square. We are dividing by 1 plus x square. In this whole equation, we are getting a dy over dx plus 2x upon 1 plus x square into y is equals to 1 upon 1 plus x square whole square. Correct? Now the value of p, this will be 2x upon 1 plus x square. The value of q will be 1 upon 1 plus x square whole square. So integrating factor, this will be e to the power integral p dx is equals to e to the power integral the value of p. This is 2x upon 1 plus x square into dx. Students, we know very well the integral of this 2x upon 1 plus x square, this will be log 1 plus x square. You will find integral by substitution method. This will be t. After solving, you will get integral of 2x upon 1 plus x square will be log 1 plus x square. Now log and e will be cancelled out. We will get here 1 plus x square, the value of integrating factor, if. Students, we know what is the solution of this differential equation. The solution will be if into y is equals to if into q into dx plus c. The value of integrating factor is 1 plus x square. We can put here 1 plus x square into y is equals to integrating factor. This is 1 plus x square. And the value of q, you can see here 1 over 1 plus x square whole square into dx plus c. Now one power is cancelled out and we can write here 1 plus x square y is equals to integral of 1 upon 1 plus x square. This will be tan inverse x plus c. Students, you can see here the value of y is 0, the value of x is 1. Correct? Now we will find the value of c here. We are putting here x equals to 1. So 1 plus 1 square is 1 and y is 0. Tan inverse, the value of x is 1. After solving, tan inverse 1 is pi by 4 plus c and this will be 0. So c will be minus pi by 4. This value of c we will put in this equation number 1. So this is your general solution. 1 plus x square y equals to tan inverse x plus c, but particular solution will be 1 plus x square y is equals to tan inverse x. In the place of c, we will put here minus pi by 4. So this will be our answer.